Okay, I think we are live here. So hello, everyone. We will wait about 2 minutes for everyone to come in, and then we'll start our talk today. In the meantime, if you come in and you can see me, you can hear me, please do drop some comments in the chat and let us know where you're coming from. Let us know who you are. Let us know what you do. We're always interested in learning about the people who come to these sessions. But like I said, we'll start with the official talk at around the 2-minute mark. So for now, we'll just kind of wait for people to trickle in. Okay, we're about 1 minute into the stream, so we're about 1 minute out from starting the official intro and then the official talk today. So today's topic is AIOps for SRE, how AI is redefining operations and reliability practices. And we'll get to hear from Arun Pandiyan-Perumal. And we'll get to hear from him in about 30 to 45 seconds here. In the meantime, like I said earlier, if you are joining us here today and you can hear me, please do let me know in the chat where you're coming from, what you're doing, what company you're at, things like that. Okay, so we are hitting the 2-minute mark here. So we'll start with just a quick introduction. I'll talk to you a little bit about me, about the community, about what we do. So my name is Yujin Tang. I'm the founder of OSS for AI. OSS for AI is a large open source community, and it stands for Open Source for AI. We primarily focus on developer education, technical topics, and startups. We've been around since 2024. And we have about 47,500 people for our live events. And we have an online subreddit called AI Agents. That's AI_agents that has about 350,000 people in it, that does about 4 million views. That's a very good place to go talk about AI agents. If you're interested in hearing about what people are doing, that would be your place to go for that. This speaker series today that we're doing is part of our efforts to give more developer education in a remote fashion. So we do a lot of live events in Seattle, in San Francisco, and New York. And so we're bringing some more online talks here, and this is part of our online talks. So today we'll be talking about AIOps for SRE, and this is how AI is redefining operations and reliability practices. And our speaker is Arun Pandiyan-Perumal, who is a site reliability engineer at Adobe, who has more than 10 years of technical experience in this space. Today's talk will be about site reliability engineering, which has always been about reducing toil, improving reliability, and helping teams respond faster when systems fail. AIOps is changing how work gets done by bringing AI-driven insights, automation, and closed-loop remediation into day-to-day operations. And this session focuses on how AIOps is transforming the way SRE teams detect, understand, and respond to reliability issues before they become customer-impacting incidents, and how SRE teams can use AIOps to move beyond reactive monitoring and manual incidents response towards intelligent, policy-driven operations. You'll learn about how AI can help detect early signs of service degradation, correlate signals across logs, metrics, traces, events, and configuration changes, accelerate root cause analysis, and recommend or trigger safe remediation actions. You'll also learn about how AIOps can minimize alert fatigue, detect early warning signs before outages occur, accelerate incident response, and turn operational data into actionable insights to improve reliability. This talk will also cover practical considerations for adopting AI responsibly, including data quality, model trust, human-in-the-loop decision-making, governance, and the importance of clear operational guardrails. A key takeaway from this session is the practical understanding of where AIOps delivers the most value, how to integrate it into existing observability and incident management workflows, and how to measure its impact using reliability-focused outcomes such as MTTR, lower toil, improved signal quality, and stronger service resilience. The whole presentation will run about 40 minutes with 15 minutes of Q&A at the end, and we are sponsored by Cracking Generative AI. So I will now bring Arun to the stage and we'll get started. Arun, welcome.
Yeah, thanks, Eugene. Thanks for the introduction. Is my screen visible?
Yes.
Okay. So yeah, let me start. Yeah, thanks everyone. Thank you for joining the session on AIOps for SRE. So we will focus on how AI is changing the way SRE operations and reliability engineering teams detect the issues, risk, and even diagnose the incidents and how they respond safely in production environments. So we will look at the operational pain points the SRE teams generally face, and where the monitoring begins to fall short, and then how AIOps can help with anomaly detection, even correlation, root cause analysis, and even how it can remediate safely. So before beginning the session, I would like to introduce my background is in the cloud platform engineering and the technology infrastructure, and I primarily focus on cloud infrastructure, DevOps, SRE, and cloud platform engineering, and also being actively involved in research activities. Like I contributed multiple research papers in IEEE and Springer, and also participated as a technical program committee member for major IEEE conferences. To start with the introduction, I believe many people are aware of SRE. SRE is nothing but site reliability engineering, as a practice of ensuring the reliability of the cloud systems or even the on-premise systems to ensure the applications running in those systems are highly available without any major impact. So the SRE is moving from mostly a reactive model towards proactive reliability engineering. So in many environments, SRE teams still depend heavily on dashboards, static thresholds, and even alert-driven mechanisms. So that been working reasonably now, where the systems are configured in a simple way. But today, we operate across multiple environments like microservices, Kubernetes, hybrid cloud, CI/CD pipelines, and that becomes more complex. So the challenge is not tracking the data from multiple environments. We need to gather metrics, logs, traces, events, and runbooks. This is where the SRE teams often have to track the data and then analyze it and fix the issue whenever it occurs. So now when we have the AIOps in place, AIOps enables AI, machine learning, automation together, and it applies those technologies to operations to help SRE teams to detect anomalies earlier, and it can help to figure out the issues, like what is occurred, and even it help generate some in root cause analysis, so how the issue has occurred and how it can be remediated in the future. So for SRE teams, the opportunity is to reduce the toil and reduce the MTTD and MTTR to improve the quality of the operational outcomes. So so the future is not completely autonomous. It is AI that supports the SRE practices. So where SRE teams can remain accountable for the environments, for managing the environments, and the AI can accelerate the operations that SRE teams handle. So before we talk more about AIOps, so SRE is built around measurable reliability. So it basically revolves around SLOs, error budgets, and automation. So the SLOs help teams define what reliability means from a user and the service perspective, and error budgets focus on like balancing the reliability with the velocity of the product that's been delivered. And automation and tooling focus on reducing the manual tasks, and also how we can reduce the toil with the manual tasks. So what are the challenges or the complexities in these days? So because when SRE teams like handle issues, they face large amounts of alerts and incidents, and those alerts and those alerts and incidents can come from multiple sources, and that troubleshooting process can become complex as well. So when the system scale, operational cost and complexity of that management also increases. So here in this stage, like we can even leverage AIOps to redefine how the SRE teams works, and it helped the SRE teams to apply those principles to improve the process. So what AIOps can do for SRE? So AIOps, like we can we just are not focused only on the dashboards or AI dashboards, but it connects the data to operational context. So it focuses on like what services are affected, and how we can provide a recommended action to resolve the issue. It is definitely not a replacement for SRE practice. It actually helps SREs to diagnose, summarize the issue, and even support how the issue can be remedied in the future. In production environments, right, in any action should be governed by the policies, right, and it also needs to be verified before executing it. So the working definitions, like for the AIOps for SRE, should focus on analyzing the telemetry, topology, incidents, runbooks to detect reliability risk, and also it needs to actively diagnose and safely remediate or even recommend what action needs to be taken. So what AIOps can improve within SRE, specifically focused on SLIs and SLOs. It can optimize the reliability targets. How we can optimize the issues that's been repeatedly faced by the SRE teams, and also it also it should also help understand the error budgets, so the instance with higher budget can be resolved as soon as possible. And at last, it also needs to analyze the latency, traffic, errors, saturation whenever we receive the data from multiple sources. And at last, the toil reduction. It also needs to help remove repetitive manual work and automate any task that can be easily resolvable. Also, it should help SRE teams to create the run books for future remediation. So this is the SRE reliability control loop, how AIOps can operate, starting with observe, right? Initially, we receive the data from multiple sources, the telemetry, like you can receive the data from AWS or Azure, from on-prem. Based on that, we collect the data. And then if any issue occurs, the AIOps can reason in the sense like analyze the issue. And we can also do some assessments like what kind of issue, how this can be categorized, whether it's like severity, it's highly severe or low severity, and it should plan like what remediation or what action needs to be taken. Based on that, it acts. It uses it can use the tools to analyze that issue. To take action on that issue. Like it can create any tickets. It can even create some summarization, like what kind of issue and how it can be resolvable. And at last, like if we have a runbook configured, then the act step can invoke those runbooks for remediation. And once the task is completed, it can verify like whether the task is completed or not. And at last, it learns like what it has done in the previous step, whether it's resolved or not. If that step got failed, how it can be resolved in the future. These are some of the use cases from SRE point of view, like SRE and reactive monitoring to policy governed AIOps. Like from the reactive monitoring perspective, we can configure like reactive monitoring, unified observability, like where we can configure the observability from multiple sources like AWS, Azure, or on-prem. And with that data, we can configure the AIOps, like root cause analysis, and even we can create a workflow for remediating certain issues. And also we can use AIOps for the policy governed remediation. Like we can involve some human approvals before any actions can be taken up. And at last, like we can also configure a closed loop remediation, like where it can perform some action without human approvals to fix certain issues. This kind of a reference architecture. So first is the sources, like where we can get the data from multiple systems, like it can be applications, Kubernetes environments, cloud, AWS, Azure, or on-prems, in any systems. And the second one, like second layer, where it is where we collect the logs or metrics or telemetry data. And once we collect the data, we just analyze like the data. And then we categorize like what kind of data based on the service ownership, environment, region. And then the fourth layer, like storage and knowledge. Here, it categorizes the logs, traces, and then the metrics as well. And the fifth layer is the here we have the AI and ML. We can even deploy AI agents, or even you can use some cloud native AI services. With that AI services, like we can perform like anomaly detection, forecasting, clustering, root cause analysis. So once those steps are completed, the next one is like action. Like incident, what action that we can take based upon the analysis. So, and at last, like when it's about to perform the action, it uses the run books, and it also initiate the request to the users for approval. And if it fails, like it also analyzes like how that can be rolled back. Yeah, generally for AIOps, observability, the pillars like metrics, logs, traces, or events, those components are important for AIOps to understand how the environment works. Because the AI cannot reason effectively without these signals or the data. So metrics, the metrics like tells us like what is happening within the systems. Logs provide some detailed event information, and traces provide how the applications work, or how the requests move across or like transfer across the services. So when these metrics, or when these signals or the telemetry data integrated, the AIOps can perform the alert detection and even build the context, like how the issues can be resolved. And it also can help answer or summarize the incidents, and it trigger actions to either resolve that issue or provide the summarization how it can be resolved. Yeah, and the AIOps primarily depend on these data. If the data is quality is not good, then the effectiveness of that solution may not be properly implemented. So this is a use case like how we can build a unified observability pipeline. So unified observability is nothing but a pipeline that collects the data from multiple sources like AWS, Azure, and on-prem, and how we are normalizing and gathering the data, and how the pipeline is built. Like it correlates all the signals across diverse data sources to provide the insights with even unified dashboard. We can even have dashboards like to categorize the environments, and this helps like streamline and reduce the mean time to detect and the mean time to resolve for multiple environments like AWS, Azure, or even the on-prem. So these are core components. We have the telemetry, ingestion, and data collection. We collect the data, and then we normalize it based on the data. We receive the AI agents or the AI services can get in. Start analyzing the data, and if it found any anomalies, any issues, it performs the action. Like it can trigger an alert or even creates incident, and it can even invoke some run books to resolve the issue. And at last, we have the visualization and dashboards. We can use like Grafana to create the dashboards and understand like how the environments are. How the environments are performing. This is the overall architecture. Like we have like data plane, control plane, AI agents plane, and then the operation plane. So the data plane, like we have the resources from AWS, Azure, and on-prem. And the control plane, this morely focused on AWS part. Like on the control plane, we have like the services like CloudWatch, Prometheus service, and AWS X-Ray. So these services collect the data, normalize it, and the AI agents read that data. Like we have like RCA agent, runbook agent, remediation, verification. So these agents analyze the data from the control plane and takes action with the tools from the operation plane, like the CloudWatch alarm. It helps to trigger the alarms, and then the AWS system manager, instance manager, it takes care of managing the instances, and also the systems manager automation. We can configure certain run books in that using that service, and the agent can use the run books to perform certain actions. So again, this is the observability data flow. Like we collect the data, and based on that the data, like we aggregate logs, metrics, and traces, and all those sent to that one centralized observability track for analysis. And then it decide the AI source decide like whether based on the analysis, like it triggers the notifications. Also, it can even invoke run books to remediate any issues that it found. So there's the components of AI agents, like what we have within AI agent. Like it's generally most of the agents or AI agents are built using the LangChain framework, and it uses an LLM as the brain of this AI agent memory, and the vector RAG, vector database for RAG, and then the tools and MCP servers. So yeah, as I said, the framework, the LangChain framework, or like any, we can also use any other similar orchestration that helps us to build that AI agent. It organizes the AI agent components, these LLM, memory, RAG, vector database, and then the tools. So the agent memory actually preserves the relevant context from previous instance or test. The vector database like holds the data that can be used for processing or like handling certain tasks. And then the tools like it helps us to interact with other services and even talk to any other system that it requires. So this is what like closed loop remediation. Here, mostly we don't require any human approvals to complete a certain action. For example, we receive a signal or data from a source, and the AI agents or the any AI services decides like what kind of issue it is based on its analysis, and it can invoke a run book to resolve that issue. Once that here in the step, like we can auto approve a certain task, or else maybe we can also invoke some human approvals if required. But for the closed loop remediation, mostly we'll choose like auto approval. And then once the task is completed, it will verify whether the task has been completed or not based on the runbook configuration and then the instructions. And if it found like the task was not completed as expected, it can perform the rollback. So how we can perform the AI root cause analysis with AIOps? So root cause analysis is the one of the the strongest aspect of AIOps because incidents can generate large volumes of evidence or from across many sources, right? So the process starts from the evidence collection like SLO, burn windows, or relevant traces and slope pans, error logs, even any recent changes within the system. So these things like help us to collect the evidence, and then we perform the hypothesis ranking. We rank the hypothesis by correlating the symptoms to topology, comparing against any prior incidents, and then we can also like score that. We can identify like how many times this issue has occurred before. Based on that, like we will perform what is the next best action. Yeah. So when it identify like based on the hypothesis tracking, it detects like what runbooks can be invoked, and then how it can be mitigated or rolled back, and then which service owner can be invoked, or and also it helps provide the summarization like how this issue has occurred, how it can be remediated. So this is the example as the output, how it can look like. Yeah. So how we can use the LLMs and RAG in SRE workflows, like primarily for, as I said, like we can use it for incident summarization whenever an incident occurred. Like we can use it to analyze the impact timeline, how that, what is the state of that issue and how it can be resolved in the future. And also we can use the RAG to store any runbooks. If any issues occurred, we can use the RAG to invoke the runbooks for any issue resolution. And also we can even use it for like incident lookups. Like if any issues occurs if there are any issues occurred in the past, we can compare those issues with the current issue and understand like how it can be resolved. And also we can use it for post-mortem drafting to assemble, to understand what are the factors that have contributed to that issue, and what are the action items that we can take for if the issue has reoccurred in the future. And these things can be achieved with the LLMs and RAGs within the SRE workflows. So what are the automation guardrails that we can use for AIOps within if we move towards the production? So the production automation definitely needs to be governed by these guardrails. So guardrails, as you know, like we are just ensuring the AI agents do not perform any unreliable action that can cause an impact to the entire system. So we just providing some instructions to the AI agent to follow as per our requirements. So the safest, the default is the first one is the read-only access. So where the system can observe, summarize, correlate, and recommend before it's allowed to act. And the second one is the least privilege. Like we need to provide least privileges to the agents to act upon. So it ensures the agent or the automation only has the permissions required for a specific task. And in the approval gates, here we can, if you primarily look for a closed loop remediation, mostly it would require like auto approval, or in any production, I mean, mostly in the production use cases, we would require a human approval to be approved to proceed to give AI agent approval to proceed further with remediating any issues or taking any action. And then the blast radius limits, like it keeps the remediation scope to a particular service, maybe an account or even a node group. If there are, if the blast radius, or I mean, if that specific account is so critical, then we can limit the AI agents functionality to a certain extent. We don't need to provide like more, substantial access to the AI agents to take actions on any certain accounts. Yeah. And at lastly, the automated verification, like it comes. I mean, this thing like is really important. One of the steps once an AI agent completes its action, it's important to verify like what action it took and how it resolved, and whether it actually followed the instructions given by the users, and it is all in within the limits. So yeah. So yeah, the next one is the operational metrics to measure. Um, AIOps should be measured primarily with operational outcomes, like how that AI service perform, like AI agents perform, not just like how it handles certain tasks. Like for reliability, we measure SLO compliance, error budget, and then incident reoccurrence. These shows whether the platform is actually becoming more stable or not with the use of AIOps. So yeah, for speed, like we need to measure the MTTD and MTTR, and the time to mitigation, and also the time to identify the root cause, like how fast it was able to recognize the issue, and how fast it was able to resolve the issue. Yeah, and these things like show how AIOps is improving that incident response, one of the major factors for AIOps. So for toil, like we need to measure the, I mean, it's recommended to measure the percentage of incidents with automated steps, and how many hours we saved for on-call rotation, how many tasks were automated with AIOps to reduce the toil within the SRE teams. And at last, the safety, really important step. Like so whenever an agent completes a task, it's important to verify and learn from it, and also need to ensure the if something goes wrong, it needs to have the capability to roll back, and it needs to ensure that it doesn't violate any other the instructions that was given to it, and also we need to constantly perform the auditing to understand like how the AI agents perform. So here, in this slide, we focus on like how we can apply AI responsible AI controls for AIOps, for SRE practices. Like so, AIOps also needs these AI controls because operational environments contain sensitive data, some maybe high-risk actions and advisorial or any other confidential data. So the model trust, the first one, that starts with offline validation or these shadow mode testing, precision, and recall tracking. And the other one, like we need to implement a human oversight. Like we need to implement the human in the loop for any high risk changes that agent can take or implement. So we need to have the users must put like accountability and even escalation path if something goes wrong. And the other one is the security and privacy controls. Here, we need to, it's important to redact any sensitive information for any unrecognized models or some, if the models are not a kind of open source or something, it's certain data, it's recommended to, redact or maybe like hide the data, which is not recommended to use within some open source models. So it's really important to apply some least privileges there to restrict the certain access to some of the open source models. And it's already always important to encrypt the data and apply some audit controls there. And also for AIOps, like the data that we send, like kind of the logs and tickets can also may contain some malicious data, may or not. Like we came across some like prompt injection issues, like those risks can even cause impacts to the AIOps service. So it's important, always monitor like what data and are being sent to the AI agents or the service. And the other one, the governance life cycle. So here, governance must include like AI inventory, risk classification, prompt and model change management, and continuous periodic reviews. And at last, the auditability. It requires some storing recommendations like prompts, approvals, and outcomes, like how the AI agent been performing and how the AIOps managing things within the SRE workforce. Yeah, thank you. Yeah, to conclude, like AIOps is becoming an important aspect in these days, especially for SRE, for managing the cloud infrastructures and for automation as well. The strongest use cases are like implementing the observability and for root cause analysis, and then also summarize issues and detect anomalies. So these things really help in day-to-day operations for the SRE teams. Yep. Yeah, thank you for it.
Yes, thank you very much, Arun. Okay, so if there are any questions from the audience, I'd love to start bringing some of these questions up, and Arun can answer them for you. In the meantime, Arun, why don't you tell us a little bit about what you guys are using to measure your success with these agents in production?
So we continuously monitor the AI agents. We monitor like how the AI agents resolving the issue, what steps it takes to perform certain actions. And then we primarily focus on the SLOs and SLIs and the instructions given to the AI agents, how they work and to resolve certain issues. We also provide the run books. When we start with, we do not provide AI agents to handle complex scenarios. Like we configured AI agents to handle certain low priority tasks. So especially in production environments. So we analyzed like whether AI agents were able to consistently complete the task as configured to do so.
How do you measure that they're consistent in completing these tasks? Like, do you have a data set that you measure against? Do you have certain ways to measure the outcomes? Like, how do you do that?
We have certain data sets. We configure the temperature of the AI agents to the point one or something to get the same data, like the same functionality, how it needs to respond to certain issues. And we have the we collect the incidents, like how it was handled, and we check like how each incidents were resolved, whether the AI agents were following the same instructions were given to or like configured before.
Got it. Cool. And someone has asked a question here. What is the signal data volume that you're dealing with, and what are you using the LLM for?
So we primarily use the LLM for the AI agents, and we do not. I mean, our use case is not so significant. We use only for like low risk or low level priority issues. So the data that we send is very low. Like as of now, only the high priority incidents are all taken care by our teams. But if they are like repeatable tasks, like low priority tasks, like we route that to the AI agents to handle.
Got it. Okay. And then I think someone's asking about the questions about least privilege principles attached to agent sandboxes. And do you see these sub-agents being spawned as inheriting parent permissions or as a completely separate class?
With respect to the least privilege principles, we provide certain access to the AI agents. Like if it requires to, I'm not sure about like the sub agents we are referring to, parent permissions or a separate. So we have like a multi-agent system, right? So one agent performs an action, and that agent puts that information into a state. The other agent picks up like what the previous agent worked on, and then it takes care of it. So the least privilege which I was mentioning, like it's more related to what level of access that we give AI agents to the systems.
Okay. Okay. I guess we'll wait a couple minutes, see if there's another question coming in. Let's see. Can you provide some examples of where the system works well and where it might be lacking?
Yeah, that's great. So as I said, the system works well when it understands like frequent resolution of like kind of low priority tasks. Or for example, we primarily use it for completing some file systems. Like kind of more. So I mean, I don't want to provide more information on that. It works pretty well when handling certain low priority tasks. But I don't want to review like what kind of tasks are there. And then it somewhat it's lacking in summarizing or maybe creating some certain tasks, or even understand like how that issues can be resolved, like for future remediation. Maybe like certain things are missing when doing some root cause analysis. So we need to constantly update our documentations or the run books. Run books is primarily for taking certain actions, but the documentations about the projects, we need to constantly maintain it. And if something goes outdated, the summarization that we get seems to be not relevant.
Cool. Okay. I think that we can wrap it up here. Thank you very much, Arun. Thank you, everyone, for coming. Someone asked one more question. So what RCA algorithms are you using?
Algorithms in the sense, sorry.
I'm not sure what RCA means.
Yeah, RCA primarily focus on the root cause analysis. Yeah, so we help. I mean, AI agents generally help like where the issue gets started, and then understand like what are all the factors that may contribute to that issue, and then how that issue can be resolved. Like it can provide some the steps for resolution, or even to remediate that issue in the future.
And what kind of algorithms are you using to assign the agents to these things? Or assign the agents via your analysis once your analysis is complete?
I'm sorry, I'm not particularly sure on that.
Okay. Cool. Let's see. Okay, it doesn't look like there's any more questions at this time. So I think we'll wrap it up and call it a day here. Thank you very much for that talk, Arun. Thank you everyone for coming. If you guys want any active ways to practice your generative AI skills, please do check out crackinggenai.com. And I will see you guys all next week.
Thank you. Thanks all.